So let's consider this function. They say the graph of f of x equals x plus 4 into x minus 6 is drawn below. The parabola cuts the x-axis at B and at D respectively, and then it cuts the y-axis at G like that. And then they say C is going to be the turning point of this parabola. And then the line AE has an angle of inclination of theta, and it cuts the x-axis and the y-axis at A and E respectively. And then they say T is going to be a point that is between B and G, like that. So what is the question then? The first question says, write down the coordinates of B and D. And then after finding the coordinates, calculate the coordinates of C. And then tell us what is the range of F, like that. So please take a picture of this because we have to move to the whiteboard. So let's go to the whiteboard. So we know this is the function we are given. They said f of x equals x plus 4 into x minus 6, like that. That's what they said to us. And then they said we need to write down the coordinates of B and D, like that. So we know these are the x-intercepts. And one thing we realize is that the function is already given in factored form. So we don't need to expand it. So we just say every time we need to find the x-intercepts, we must let y to be 0, like that. Then from this point, we apply the zero factor law. So meaning x has to be -4 or x has to be +6. Now, if we look at our graph, we can see that B is on the negative x-axis. So meaning the coordinates of B have to be -4 and 0, because at the x-intercept is where y is 0. And then the coordinates of D will subsequently be 6 and 0, like that. Fine. Now the second question says, write down the coordinates of C. And we know that C is the turning point, right? So we can do it in many ways. But now the first thing I want us to do is to expand this function. So we use the FOIL method for that. So we say x times x, we get x squared. And then x times -6, we get -6x. And then we say 4 times x, we get +4x. And then 4 times -6, it's just going to be -24, right? Yeah, 6, 12, 18, 24. Awesome. And then from this point, we say it's x squared. Then -6 plus 4, it's just going to be -2x. Then we say -24. So this is our function in expanded form. Fine. Now here you have 2 options, in fact 3 options when finding the x-coordinate of the turning point or the turning point in general. So the easiest you can say is when finding the x-coordinate of the turning point, you say -b divided by 2a. Then you say negative into, the value of b is going to be -2. And then you say 2 into, the value of a is going to be +1, like that. So negative by negative is a positive. 2 divided by 2 is just going to be 1. This is the first way you can find the x-coordinate of the turning point. What is the alternative? So now that you are in grade 12, you understand that at the turning point or the stationary point, it's where the derivative is equal to 0. So what am I saying? You find the derivative and then you equate it to 0. Then you find the x-coordinate of the turning point. So let's go. If you differentiate this function, you are just going to get 2x minus 2 like that. But you know that at the turning point, it's where the derivative is equal to 0 like that. Then you take negative 2 to the left, it becomes positive. You are left with 2x there like that. And then what are you going to say? You divide both sides by 2. So this means your x equals positive 1. Alternatively, what could you have said? You could have said, because you understand that the axis of symmetry passes through the x-coordinate of the turning point. So you could have said, if you must find the x-coordinate of the turning point, you just need to find the midpoint of your two x-intercepts. So you say it's going to be negative 4 plus 6, and then you divide this by 2. So negative 4 plus 6 is positive 2. Divided by 2, you realize that your x is going to be positive 1. So you have 3 ways of finding the x-coordinate of a turning point. Fine stuff. So because you now have the x-coordinate of the turning point, what are you going to do? You must substitute this x-coordinate into the original function to find the corresponding y value. So let's go to this function. You can choose this one, or you can choose this one in factored form. It's up to you. So if we go to the expanded one, we want to know what is the y value when x is positive 1, like that. So here 1 squared is 1, and then 1 minus 2 is negative 1. Negative 1 minus 24. So it means the y coordinate of the turning point is just going to be negative 25. So what is the meaning of this? It means the coordinates of point C are going to be positive 1 and negative 25. But if they were to ask for the coordinates of G, we said G is the y-intercept of F. So meaning the coordinates of G will be where x is 0, y is negative 24, like that. But in this case, they didn't ask for the coordinates of the y-intercept. That's fine. So now that we have the coordinates of C, the next question says, write down the range of F. I think we need to see the graph for that. So what is the range? It's the y values for which the function is defined. So in other words, where does the function start in terms of y values and where does it end? That's your range. So if we give this function a good look, we can see that in terms of the y values, it starts here and then it goes upwards all the way to positive infinity. That's what we can see. So now that we say that, what is the meaning? So this means if we must talk about the range, we'll tell them that the function starts where? At negative 25. And where does it end? It ends at positive infinity. But because it starts at negative 25, we need to include this negative 25. So you can say it like this, or you can say any y value that is greater or equal to negative 25 will make sure that this function is defined. So yes, these are the two different ways in which you can state your range. Fine stuff. So we are done finding the domain and finding, sorry, not the domain, the range as well as the intercept and the turning point. But if they ask you the domain, then you should know always for a parabolic function, the domain will be an element of all the real numbers. How do we know that? It's because the function comes from negative infinity in terms of the x values, and it goes all the way to positive infinity. So these arrows, they show us that the function goes all the way to negative infinity. It goes all the way to positive infinity in terms of the x values. The same holds for y values. It goes upwards all the way to positive infinity. So that's why your domain is going to be any value of x from negative infinity to positive infinity. Okay, that's fine. That's fine. So let's look at 7.4. They're saying if it is given that theta is equal to 14.04, and it is also given that the tangent to f at t is perpendicular to AE. So firstly, we want you to calculate the gradient of AE, correct to 2 decimal places, and then you have to find the coordinates of point T. So let's talk about the gradient of AE first. So they gave us the angle of inclination, right? So here they are taking us back to analytical geometry. Who thought they can take paper 1 and paper 2 and put it together? Not bad. So in analytical geometry, we learned that the gradient of AE, I'm sorry, not the tangent of AE, the gradient of AE. So we know that the gradient of AE is actually equal to the tangent of theta, the tangent of the angle of inclination. That's what we learned in analytical geometry. So here we understand that the angle of inclination is 14.04 degrees. So how much is it going to give us if we press it into the calculator? So they said correct to 2 decimal places, it's going to be 0.25, like that, which if you prefer, you can say 1/4. But they said to 2 decimal places, so meaning you can't say that. You need to have a little bit of respect for the instructions, of course. Fine. Now we know the gradient of AE, but listen to what they are saying. They are saying at point T, there's going to be a tangent to the curve. So meaning T is the point of tangency. That's fine. But now they are saying this tangent is going to be perpendicular to the line AE. That's what they tell you. So now that you have that information, they ask you to calculate the coordinates of point T. So point T, which is just the point of tangency. So what are you going to do? One thing you know that the gradient of a tangent at a certain point on the curve is equal to the gradient of the function itself at that point. So what am I saying? I'm saying you need to know what is the gradient of a tangent line. So now that you know the gradient of a tangent, you automatically know the gradient of the function itself at that point. So what I'm trying to say, let's find the gradient of the tangent at point T. So this is what they told us. They told us that the tangent and the line AE are perpendicular to each other. So they are taking us back to analytical geometry again, because we learned that if 2 lines are perpendicular, then it means the gradient of the tangent multiplied by the gradient of AE must give me -1. That's what we learned. So we are looking for the gradient of a tangent, but we know that the gradient of AE is 0.25, which is just 1/4. So everything is equal to negative 1 like that. So if I were to solve for the gradient of the tangent, I need to multiply throughout by 4. So if I say this multiplied by 4 like that, then it means the gradient of a tangent line is just equal to -4. So now I have the gradient of a tangent. But what do I know? I know that at the point of tangency, it's where the gradient of a tangent is equal to the gradient of the function itself. So what is the gradient of a function? So we know that the function itself is going to be x squared minus 2x minus 24. That's what we said. And then we also said the gradient of the function, which is the derivative, it's equal to 2x minus 2 like that. So this is the gradient of the function itself. But we know that at the point of tangency, it's where the gradient of the tangent and that of the function are equal. So because it's where they are equal, you might as well equate them like that. And then you take this -2 to the other side. So you just get -2 like that because it becomes positive. So -4 plus 2 is -2. And this is equal to 2x. So looking at this, it means the value of x is going to be -1. So we know that the x-coordinate of the point of tangency is equal to -1. So now that we know the x-coordinate of the point, then we just need to find the y-coordinate. How do we find the y-coordinate? We substitute this into the original function. So meaning where I see x, I put -1, and then I put that, then I say minus 24. So -1 squared is 1, and then negative times, in fact, -2 times -1 is +2. So 1 plus 2 is 3, and then 3 minus 24, it's just going to be -21. So what is the meaning? It means the coordinates of point T is where x is -1, y is going to be -21. And it makes sense because -1 is between -4 and 0. And -21 is between -24 and 0. In fact, 0 and -24. So yes, because they told you T is between B and G. So this makes sense. How did we find it? We had to find the gradient of a tangent, and then we differentiate the function because we know that the derivative is actually the gradient. So because the gradient of a tangent and that of the function itself are actually the same thing, so we equate them. And then we find the x-coordinate, then we can find the corresponding y value by substituting into the original equation. Yes, so I hope this makes perfect sense. Okay, that's fine. Now, what is the last question? Let's go to the question itself. So the last question says, a straight line G is going to be parallel to AE. But what is important, it cuts the parabola at K and at R. So yours is to calculate the x-coordinate of R. That's what we know. So we understand that K and R are going to be the points of intersection. That's what we understand. So we know that we are going to have a function, or rather a straight line that is parallel to AE. So it's taking us back to analytical geometry again, because we understand that if two lines are parallel, then they have the same gradient. That's what we know. So it means we now know the gradient of this straight line G. So now that we know the gradient, we also know one point through which G passes, which is point K. So meaning the first thing we can do is to calculate, or rather determine the equation of G. So now that we have the equation of G, we are going to equate f of x to g of x in order to find the x coordinate of R. Why? Because R is another point of intersection of the two functions. Yes. So let's go to the heart of it. We're killing these things. So they said G is parallel to AE, meaning the gradient of G of x is just going to be 1/4 as well. So they said G passes through K, right? So meaning K is a point on G, so we use it to find the equation of G. But since G is a straight line, we can say y equals mx plus c, or we can say y equals ax plus q, whichever one you prefer. So we know the gradient is 1/4. The x coordinate of k is going to be -3. The y coordinate of k is going to be -9. We are looking for c. It's the only thing we need so that we can have the equation. So here we are going to have -3/4 plus c, which is equal to -9. So how much is -9 plus 3/4? So we realize that the value of c will just be -33/4. What is the meaning of this? It means the equation of g of x is going to be y equals 1/4x minus 33/4, like that. But because it's a function, I think it's wise to write it in functional notation. So we are saying g of x is equal to this whole thing, like that. But now what do we know? We know that K and R are the points of intersection. So what are we going to do? We must equate these two functions because we understand that where they intersect is where they are equal. So your g of x will just be 1/4x, and then you say minus 33/4 like that. F of x in expanded form, it's going to be x squared minus 2x minus 24, like that. Now we have an equation and then we have the fraction. We hate fractions if we are working with equations. So the best thing we are going to do is to multiply every term by the LCD. And our LCD in this case, it's going to be 4. So we multiply every term by the LCD. So 4 times 1/4x, you'll just get x. And then 4 times -33/4, you'll get -33. And then you say 4 times x squared, you'll just get 4x squared. And then 4 times this will give you -8x. And 4 times 24. How much is that? So 4 times 24 will just give you -96, like that. Then from this point, we want to write everything in standard form. So let's take everything to the right. So we still have our 4x squared there. And then you say -8x minus x. It's going to be -9x. Then you say -96 plus 33. It's going to be -63, like that. Now, from this point, we know that it's going to be a little bit of a challenge if we must open two brackets when trying to factorize this. So we'll just go straight to the quadratic formula. So I'm not going to write the quadratic formula here. No, I'm not going to write it, but I'm just going to write the final result. No, let's just write the quadratic formula. And maybe we should substitute and find the final answer. So you have negative into, the value of b is -5, sorry, -9. So here you have -9 squared, then you say -4. A is going to be 4, and then C is going to be 63, which is negative, of course. And then the whole thing is going to be divided by 2A. So you say it's divided by 2 multiplied by 4, like that. So let's see how much we get. So the first x coordinate we get, it's going to be -3. What about the second one? So the second x coordinate will just be 21/4, like that. So it makes sense for us to get x equals -3. Why? Because they told us that the coordinates of k is -3 and -9. And we understand that k is one of the points of intersection. So it makes sense to get this one. But the actual x value we are looking for is x equals 21/4. So this means the x value at R is just going to be 21/4. So if they were looking for the corresponding y value, you take this x value and then you substitute it into any of the equations you prefer, either the quadratic one, or you can say the linear one, so that you can find the corresponding y value. Yes, but we are actually done for this one. So I really hope this helps a lot. I hope you learned so much from this. I know that you've learned already, but in case you forgot some of the things or you didn't know how to apply them, so I really hope this is going to help a lot. So if you really did enjoy this video, please give it a thumbs up, a like that is, and please subscribe to my YouTube channel so that you don't miss out on any more videos I'll make. But otherwise, let's see you in the next video. Thank you so much for watching.